but it's not difficult. I think it's something that you can handle being at home. We're sure looking forward to having you back in a couple of days. Today we're going to start with this page that says 1-8 additional vocabulary support. This page is in your class notebook under section 1.8. And when we get through, I'm going to take a picture of it after I filled it out, and I'm going to put that in there as well. So let's match up these terms. Our objective today is to be able to apply formulas for area and perimeter in order to find desired values. So you've got to find area and perimeter of your house, all sorts of things in life. So it's important to know how to do those. So they've got the first one done. It says perimeter is the sum of the lengths of the sides of a polygon or the distance around a polygon. Number 2 is radius. Which of those, Cameron, do you think radius matches? Well, when you have a circle, so it doesn't go all the way across. Okay. On the circle, that's what that one is. What's diameter? That's diameter right there. Yes, the distance across the circle through the center. That's important, through the center part. We probably don't pay a lot of attention to it right now, but it is very important. And that center is always area. No, the distance around the circle is called something else. That's the circumference. The distance around the circle is the circumference. See, circumference kind of sounds like it has the word fence in it. And if you're going to build a fence around a circle, that's what that is. Circle fence. Okay. Area. We still got to pick one for area. Triangle. Yeah. Quadrilateral. Okay. Now, draw a line from each phrase in column A to its formula in column B. The perimeter of a square. What do you think about the perimeter? What do you know about a square? 4 sides, and they're all equal. So, if you're finding perimeter, I bet you originally started by adding things together, right? But on a square, you'd be adding 4 of the same. We could shortcut that, right? 4f. The circumference of a circle. You don't know the diameter and you know the radius. What's the relationship between the radius and the diameter? Multiplying by 2. That's that one. Area of a rectangle. A rectangle doesn't have to be congruent on every side. Well, that's height are always going to meet at a right angle in any shape that they give you. Rectangle, triangle, square, whatever you're talking about. If they call it a base and they call it a height, it's going to create a right angle when it meets. So to find the area of a rectangle, you just need to, you probably always heard this as length times width. Okay, but instead of length and width, we're going to call it now base and height. So the area of a rectangle is height. Area of a triangle. Now look, here's the base down here at the bottom, and here's the height, that dotted line. They make that right angle inside the triangle. Now this might not be a right triangle, but inside of there, the base and the height meet up to make a right angle. And it's perimeter of a rectangle. Sometimes or distributed, either way. Area of a circle. Or square. The diameter, they don't give you one with diameter in it, but they could. They could very easily do that. But I want to talk to you. Radius. If I wanted to solve for R, this little thing right here, what would I do? If I wanted to get the R by itself. Well, you divide by 2, right? So R, 2R equals D means the same as R equals the diameter cut in half. Is radius equal to diameter cut in half? Yes. Okay. So I don't know why. It means the same thing, but never in geometry do they talk about that. They only use that for area. How do you know which one's area and which one's circumference? That's a thing that kids get mixed up all the time. Area is going to have something squared, right? Circumference doesn't. The 2 is not used as an exponent in the circumference formula, okay? Yeah. Okay, so you've got this. This is kind of like a little reference sheet because it's got all your formulas on there now, right? Okay, there's nothing on the back of that. Here in a little bit, I'll take a picture and put that into Teams. And next, we're going to move to this. This is also in your page in section 1.8. It's area and perimeter of composite figures. But first, let's flip over and let's do some practice on the triangles. Area of a triangle. It's 1/2 the base times the height. A little asterisk here. These two must be perpendicular, which means they're going to form a right angle. So give us just a practice problem here. If we have a height of 6 and a base of 8, what are we going to do to find our area? We're going to multiply 1/2 times 8 times 6. You can do that whatever order you want to. If you want to go 6 times 8 is 48, then take half of that, that's fine. Or if you want to say half of 8 is 4, and 4 times 6 is 24. Units squared. I didn't put any units on there, we're just going to go, I didn't put inches or centimeters, so we'll just say units squared. Okay, let's do this one. What are we going to do here? Is not have more Sharpie. The next one on the back. Numbered. I'm doing these on this piece of paper because I wrote with Sharpie. Okay, so now they're telling you the area. How do you think we should start this? Yeah, let's plug it all in. Let's plug it all in. To this formula, put every number where it goes. So what goes in place of A? You have a number 40 equals 1/2. Do I know the base? It's X. I'm going to put an X. You can leave it a B. It doesn't matter. Do you know the height? 4. Okay. So you have 40 equals 1/2 times X times 4. So what you need to do is multiply the parts you can. You can actually multiply 1/2 and 4 over here. So this is 40 equals 2X. And then divide. So X is 20. Okay. Let's look at the next example. This is 2, this is 12. So equals 1/2 times 12. We're going to multiply the parts we can. And divide by 6. Any questions there? That's pretty simple. Okay, let's look at the next one. It says area is 18 units. What do you think? You don't know either one, do you? I don't know are the same variable, right? Okay, so let's just move forward like we have been doing. 18 equals half of X times X. Does that make sense? I can't multiply 1/2 times either one of those X's. That's not going to help me. But what happens when you do X times X? What do you think? How about X squared? 1/2 X squared. Let's do something with 1/2. Let's get rid of it from that side. Divide it by 1/2, which means you're going to end up multiplying it by 2. So let's do that. 36 equals X squared. Wonder what X is. What could it? Well, would you? I mean, is that what it's asking? It's asking what's X so that when you do X squared, you get 36. Or when you do X times X and it's explained. What number could you multiply by itself? 18 times 18? Check that out for me real quick. There you go. It'd be the mathematics behind it. You're looking for a number that multiplied by itself gives you 36. And you know those. I mean, I picked out something that's easy enough that you know 4 times 4, 5 times 5, 6 times 6. You know those little numbers. So x is 6. The sides of that are the same length. You could have marked them this way, right? Going back and doing some geometry. And we could have called it an isosceles triangle. Remember talking about that way back there? That's before the hurricane. Okay, so we got that done. Now let's go to place for today. I had the problems for now that I want to go to. Okay, I think it's in Teams. Did an assignment pop up in Teams? Okay, and then here's this, the problem, and there's circle. Somewhere I had it. I put this in here someplace. Can't remember where. There's all of that. Okay. So here's what I want you to do today. I want you to do number 1. And what's it asking you to find here? Area and perimeter. We're going to do that together. Okay. Now, how are you going to find the area of that shape? That's not a shape. That's like 2 put together. Yeah. I'm going to draw this. What have I created? A rectangle and a triangle. So I'm going to do area first. And how would you find the area of the rectangle? What's the base? Okay. Here's the rectangle right here, right? 30 is the length of the whole thing. So I only need the base, like this is the height, right? I need this length from here to here. Do you know what that is? Isn't it? It's 18. 18 times, how tall is it? 10. Okay, real easy, that's 180 meters squared. Now I've got to come up with the area of the triangle. You know what I need there, right? Well, those are the sides. Remember what I said about base and height having to be perpendicular and make a right angle? So I'm going to have to figure out the length of that dotted line and this line that I'm drawing in. Any idea how long this line might be? That's 10. Okay, that's my base. Now I've got to figure out the dotted line. It's not 13. Might be close to 13, but it's, how did you come up with 12? Good. Good. So half of 10 is 5, and 5 times 12 is 60 meters squared. So the area of the whole thing is Now we're going to do the perimeter. Now, perimeter is only the outside of the shape. Don't get any of those inside pieces in there. How big is that one? Was 30 used at all in finding the perimeter? No, don't think you got to use every number. Add those up. I got 72. Did you get 72? Okay. 72 meters. Now, we have to do it algebraically down here, number 6. Number 6, we got to do it algebraically. Let's find the perimeter. You don't know the value of A or B, do you? The only thing you can do is just start adding A, and I'm going to highlight as I go so that we know what we've used, plus B. Now, how big is this section here? Right there. Wonder what that is. Yeah, but I mean, how far is it from here to here? Now, a while ago, we took the whole bottom and subtracted off a piece, right? We're going to have to write this algebraically. Think about, what do you think about 3B minus A? Where'd that come from? You see, so you kind of see where it comes from? Okay, it's weird, but we see it. So let's put that in there. Plus 3B minus A. How big is this piece over here? Well, this is B. They labeled it for me. And this piece is, and this piece is 2A. Now, correct like terms. A and minus A, those cancel. The only A's I have are these two at the end. That's 2A. Then I have 1B and 3B makes 4, 5, 6, 7, 8. Okay, that one's a challenge. That one is a challenge. Okay, I want you to do on the back 1 and 5, 6, those 3, 1, 5, and 6. Okay, 1, 5, and 6.